Hello, welcome to lesson 1.9, talking about comparing distributions. Today we're going to be using box plots to compare distributions, and along the way we're going to be calculating one variable statistics for two different data sets. So get the companion notes down in the comment section and let's begin.
To compare two distributions, we're going to want to start with our calculator. We're going to run one variable statistics for each of our data sets. So let's review a little bit about using our calculator to get started with today's lesson. So today we're going to use a data set or two data sets that will have the amount of water that two teams intake per day in liters of water. So a high school soccer team and a high school basketball team, and we're going to compare their distributions. So we're going to start by reviewing how you might use your calculator to do this, to give you the statistics that you need quickly in order to compare the distributions by creating a box plot, which is maybe the quickest one to do using your calculator because you can create the 5-number summary and then quickly make the plots. This is our data, and we have data in liters of water. They're small data sets so that you can enter them into the calculator quickly, which if you needed to do that on the AP statistics test, you would be given likely small data sets. So you would enter the data. Just to recap how you do that, we're going to go to the Stat button. Once we're in the Stat button, we're going to go to the first thing there, which is Edit. We're going to click that Edit, and in L1, we're going to put one of our data sets, so maybe basketball, and then in L2, we'll put the other one, soccer, and then we're going to need to run one variable statistics for each of them. So you'll clear out of that. You'll go back into Stat, but then over to Calc and to one variable stats. We could use two variable stats, but that's not going to give us the 5-number summary. So we're going to run one variable stats twice. So when you click the Calc button, one variable stats, you're going to bring up this menu, and under List, you see L1. So it's going to run one variable stats for L1, and you just hit enter, 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 and you get these menus. So you'd want to write down like the mean. So our X bar, our sample standard deviation as X, and then our 5-number summary. Then you're going to go back and you're going to do this again after you've recorded those values, and you're going to go to Stat, Calc, one variable stats, and you're going to change the list to L2. You could do that by second function 2, and that will change that from an L1 to an L2, and you'll run one variable stats again, and it will bring up again your statistics that you'll record. So then we can easily create our side-by-side box plots. So remember that we need our 5-number summary. In this case, you can see that neither one has outliers. So our lower values are our minimums. Our lower end of our box is Q1. The middle of our box, the middle line, is our median, and the upper line is our Q3. And then our higher whisker is our respective maximums. So once you get these drawn, then it's easy to compare the distributions. So when comparing distributions, I would first look at the shape of the distributions, because that is what we would like to understand when we're going to be talking about what measures of center and variability to use in our comparison. We notice in these two small data sets that they're both roughly symmetric. So because they're both roughly symmetric, we're going to use the mean and the standard deviation for our comparisons. So we would use similar language, SOC V, plus context, but then also comparative language. So we could say the distributions of soccer and basketball teams' water intake is roughly symmetric, with no apparent outliers for either. The basketball team consumes more water, on average, with a mean of 4.1 liters per day, as compared to the soccer team that on average drinks 2.95 liters per day. The variability of the soccer team is slightly higher, with a standard deviation of 0.303 liters per day, as compared to the basketball team with 0.258 liters per day. So you notice that we did all of the things that we did for SOC-V, the shape, outlier, center, variability, and context, but then added in that additional layer of comparative language. Stay curious, keep questioning, and remember, in statistics, understanding the details quenches your thirst for knowledge.